Hello everyone. This is the second part of the discussion of competency based MCQ test papers by Kendriya Vidyalaya Sangathan. In the first part we have discussed question number 1 to 10. Now in the second part we will discuss question number 11 to question number 20. So let's get started. Now see question number 11. In question number 11 it is written that in the given figure, if quadrilateral PQRS circumscribes a circle, then PD plus QB is equals to what? So for this we have the property that if we have a circle and in the circle from an external point, we know from an external point P we can draw two tangents to the circle, right? And we know that the length of both the tangents are same or equal. So now in this figure let us consider P as the external point and this is a circle. That means the tangent PD and PA will be equal. So I am writing here that length of the tangent PD is equals to length of the tangent PA. Now this point S we can consider as an external point, and from this point also we have two tangents to the same circle and this length will be equal. So we can write that SD, length of one tangent, and it is equals to SC. Similarly, R is again one external point, and from this we have drawn two tangents. That means RC is equals to RB. And then this is the last external point, and we have again two tangents to the circle. So we can write QB is equals to QA. Okay, so we have these four cases. We have to find out the sum of PD plus QB. Now we can see there PD is here and QB is here. That means we can add these two equations. Okay, and whenever we have to add the equations, we will add LHS with LHS. So PD plus QB, and this is equals to PA plus QA. Now if we will see in this figure, PA plus QA, this is PA and this is QA. So if we will add, we are getting PQ. That means the sum of PD plus QB is PQ in this figure, and you can see this which option? It is option A. So correct option is option A. Now let's see question number 12. The question number 12 says AP and AQ are the tangents drawn from a point A to the circle with center O, and radius is given 9 cm. OA is 15 cm. Then AP plus AQ we have to find out. So this is again based on the same property. It is written AP and AQ are the tangents from an external point A to the circle. So if we have a circle, suppose, and this is the external point A, from this we have tangents to the circle, right? And tangents are AP and AQ. And O is the center of the circle. So this we can consider as O, center of the circle. Radius is 9 cm. So if I will join point P with O, so this is our 9 cm. If OA is equals to 15, OA means the distance of this external point from the center, and this is given 15 cm. They are saying that we have to find out AP plus AQ. So this is AP and this is AQ. So we have to find the sum of these two tangents. Okay, and we have discussed that the length of the tangents from an external point to the circle are equal. So if we will find out AP, that will be equals to AQ, right? Now we will look at the triangle APO. Triangle APO. We know that the tangent is always perpendicular to the radius. So this angle is 90 degree. That means it is a right angle triangle, and in right angle triangle AO is the hypotenuse. So we can say by Pythagoras theorem that AO square is equals to AP square plus PO square, right? So now AO is given 15, so we can write down 15 square is equals to AP, we don't know, that we have to find out, and PO square is 9 square. So we got AP square is equals to 15 square, that is 225, minus 9 square, that is 81. So we are getting 144. So what is AP? AP is square root of 144, that is 12 cm. Okay, and we have to find out sum of AP and AQ, and AP and AQ both are same. That means AP plus AQ is 12 plus 12, that is 24. So we can see here our correct option is option C. Now let's see question number 13. It says the value of K if P is the midpoint of the line joining the points A and B. We know if we have 2 points A and B, and if P is the midpoint, so we know the midpoint coordinates if these are x and y. So x will be x1 plus x2 upon 2, and similarly y will be y1 plus y2 upon 2. So that concept only we will use. We can see here that the points are 5, k and 3, and the B point is minus k and minus 7. And P is the midpoint, that is 4 and minus 2 it is given. We have to find the value of k. So we can see here this is the x coordinate, this is x1, and this is the x coordinate of point B, this is x2, and this is x. These are the midpoints, right? So we know that 4 equals to 5k minus k divided by 2. So we got 4k equals to 8 and k equals to 2. So we got the value of k as 2, and we can see which option is the correct option. It is C option, right? And let's see question number 14. It says a straight road connects a school located at point A. Coordinates are given. These are the coordinates of school, and a hospital at a point B. A grocery store is located at a point C along this road. The ratio in which the grocery store divides the road between the school and the hospital is. So we have to find out ratio in which this grocery store divides the line. Okay, so it is written, this is the location of the school, point A, coordinates are 1 and 2, and on the same road we have the hospital, point B, coordinates are 11 and 8. Now they are saying on this same lane we have a grocery store, coordinates are 6, 5. We have to find out that this grocery store divides this line into which ratio. So we know whenever we have to find out the ratio, this is a line and this point is intersecting the line internally. Okay, so we are using the section formula. So we will assume let the ratio be k is to 1. And we know that if this is the point which is intersecting the line internally in this ratio, so coordinates are x and y, and here coordinates are x1, y1, and here x2, y2. So we know if we have to find out the formula, we have to find out the coordinate x. So x is m1 x2 plus m2 x1 divided by m1 plus m2, where m1 and m2 is what? It is the ratio, m1 is to m2. That means m1 is k and m2 is 1. Now what we will do, we will put the value. So x is 6 here. So 6 equals to k into 11 plus 1 into 1 divided by m1 plus m2, that is k plus 1. Now we will simplify this. So we will do the cross multiplication. We are getting 6k plus 6 equals to 11k plus 1. Simplify, so 5k equals to 5, and we got k equals to 1. So we got k equals to 1. That means ratio k is to 1 is 1 is to 1. So our ratio is 1 is to 1. Now we can see here 1 is to 1 means we have the A option. That means correct option is option A. And now let's see next question, question number 15. The point which divides the line segment of points P and Q in the ratio 2 is to 3. Now this question is same like last question. In the last question we were finding ratio and the point was given. In this question we have to find the coordinate of the points which divide the line segment in the ratio. So in this question ratio is already given. So we have here point P, coordinates are given as minus 1 and 7, and then in the same we have another coordinate Q, 4 minus 3. There is a point which divides the line segment in the ratio 2 is to 3, and we have to find out the coordinates of that point. That means we have to find out the value of x and y, right? And this is our ratio m1 and m2. So we know the x coordinate is m1 x2 plus m2 x1 divided by m1 plus m2, and same way we have y coordinate, that is m1 y2 plus m2 y1 divided by m1 plus m2. So x coordinate we will put the values. M1 is 2, so 2 into 4 plus 3 into minus 1 divided by 2 plus 3. So we are getting 8 minus 3 divided by 5, that is 5 upon 5, 1. So we got x coordinate as 1. Now here we have y coordinate, again we will put the values. Now we have m1 y2 plus m2 y1. So we will put the value 2 into minus 3 plus 3 into 1 divided by 2 plus 3. So we are getting minus 6 plus 3, sorry, this is 7, okay, 7. So we are getting it is 21 divided by 5. So we are getting 15 upon 5, that is 3. So we got the value of y coordinate as 3. That means the coordinate of the point A are 1 and 3, and we can see the correct option is option D. Now let's see next question, question number 16. A ladder 20 meter long reaches the top of a vertical wall. If the ladder makes an angle of 30 degree with the wall, then the height of the wall. We have to find the height of the wall. Now here, suppose this is the wall, right, and this is the ladder. So it is written that the ladder 20 meter long. So this is the length of the ladder. It is 20 meter long and it reaches the top of a vertical wall. If the ladder makes an angle of 30 degree with the wall, so this angle is given 30 degree, right? Find the height of the wall. This height we have to find out. Okay, now we can see that it is a right angle triangle. We are using the concept of trigonometry. This is our hypotenuse, right? And we have to, this is our acute angle 30. So the side which is opposite to acute angle, this is our perpendicular and this is our base. That means we need the relationship which deals with hypotenuse and base, right? So now we know that cos theta is equals to b upon h. Here theta is 30 degree. So cos 30 is b upon h. The value of cos 30 is root 3 upon 2. And here b, that base, that means the height of the wall, that we have to find out. So b and h is 20. So if we will solve, we are getting b as 10 root 3 meter. So we can see here the correct option is option B. Let's see next question, question number 17. It's written that if a pole 6 meter height cast a shadow 2 root 3 meter long on the ground, then the sun's elevation is, we have to find the sun's elevation. Okay, now suppose we have a pole, this is 6 meter in height and it casts a shadow. Shadow will be always on the ground. So this is the length of the shadow 2 root 3 meter and we have to find the sun's elevation. That means this theta we have to find out. Now this is the acute angle. We know the angle which is opposite to acute angle, the side which is opposite to equal angle is our P and this is our B. So that means we need the trigonometric ratio which deals with the perpendicular and base. So we know that is tan theta. Okay, so tan theta is P upon B. So theta we don't know, so tan theta, and the value of P is 6 and the value of B is 2 root 3. We can rationalize this. So we will multiply by root 3. So we are getting what? We are getting 6 root 3 upon 6. 6 and 6 we can cancel. So we are getting tan theta equals to root 3. And in the table of 10, root 3 comes at 60 degree. That means theta equals to 60 degree. Now we can see that our D option is the correct option. Now let's see question number 18. In question number 18, it is written that in a circle of radius 14 centimeter, an arc subtends an angle of 30 degree at the center. The length of the arc is, we have to find the length of the arc and the options are given. Okay, so we know that if there is a circle and there is an arc which subtends an angle of 30 degrees. Suppose this is the arc and it subtends an angle of 30 degree at the center. So this is 30 degree, right? And the radius is given 14 centimeter. We have to find the length of the arc. So we know that the length of the arc is theta upon 360 2 pi r, right? Theta value is 30 degree and it is 360 degree. 2 pi is given 22 by 7 and r is given 14. So when you will solve this, you are getting 22 upon 3 centimeter. That means the length of the arc of this circle is 22 by 3. That is our option number D. Now next question, question number 19. This is assertion and reason question. Options are given A, B, C, D. Now let's see the assertion. Assertion is that in a circle of radius 6 cm, the angle of the sector is 60 degree. Then the area of the sector is. So we know that in a circle, suppose this is the circle, we have, this is the center, we have to form a sector. So this, suppose this is the sector, and angle of the sector is given 60 degree, radius is given 6 centimeter. We have to find the area of the sector. So area of the sector is this portion, and we know that the formula of area of sector is theta upon 360 pi r square, right? The value of theta is given 60 degree, so 60 upon 360, pi is given 22 by 7, r is given 6 into 6. So when you will simplify this, we are getting 132 upon 7 centimeter square. So they are saying that the area of the sector is 132 by 7 centimeter square. That means our assertion is true, right? Now let's see the reason. The area of the circle with the radius r is pi r square. So this is also correct. We know that in a circle, if the radius is r, then the area of the circle is pi r square. But there is no relationship between these two, right? Here we are talking about area of the sector, here we are talking about area of the circle. That means both assertion and reason are true, but reason is not the correct explanation of assertion. So for question number 19, our answer is B option. Now question number 20, assertion, if the radius of the base of a right circular cylinder is halved and the height is doubled, then the volume of the cylinder so formed is halved. Okay, so first let's look at the assertion. They are saying that we have a right circular cylinder. Suppose this is a right circular cylinder. This is the height of the cylinder h, and this is the radius of the cylinder r. Now they are saying when the radius of the base is halved, that means the new radius is half of this, that means r upon 2, and the new height is doubled, so new height, so here height is h, so double of h is 2h. So they are saying that the new volume will be half of the old volume. So here if we will find the volume of this cylinder with the radius r and height h, so we know volume formula is pi r square h, so volume is pi r square h. Here new volume, so again we have formula pi r square, r is r upon 2 whole square and h is 2 into h. So if we will simplify, we are getting pi r square h divided by 2. So can you find any relationship between this? This is the original volume V1 and this is the new volume V2, and we can see that V2 is V1 upon 2. That means new volume is half of the volume of the original cylinder. So here it is written, it is halved. That means assertion is totally true. Now let's see the reason. Reason is, if the radius of the base of the right circular cone of volume V is halved and the height is doubled, then the volume of the new cone so formed is 2V. Now we have a right circular cone. So suppose this is a right circular cone. This is the height of the cone h and this is the radius of the cone r. Now we know that the volume, suppose V1 is the volume, and the formula of volume is 1 by 3 pi r square h. So this is the original volume. Now they are saying that the height, the radius is halved. That means the new radius is r by 2, same what we did in case of cylinder, and the new height is twice, that means 2h. Okay, now we have to find out the new volume. So we are writing new volume. So new volume we can denote by V2. Again formula is same, 1 upon 3 pi r square. R means r upon 2 whole square. H is 2h. So if we will simplify, we are getting 1 upon 3 pi r square h divided by 2. That means its original volume divided by 2. That means in case of cone also, if we will make the radius half and if we will make the height double, the new volume will be half of the original. But here in the reason they are saying that the volume of the new cone so formed is 2V. It is twice. That means this is wrong. So we can say here in this case our correct option is option D, which say option C, which says that assertion is true but reason is false. So here assertion true hai but reason is false. Okay, so correct option is option C. Thank you.